Good morning, friends. So today I like to discuss the hybrid parameters in transistor circuit. In this circuit, we take the common emitter configuration circuit, which is supposed to be 4-port device, 2 parameters in input port, 2 parameters in output port. These parameters are current and voltage in both the sections. So let us discuss this 2-port device in the transistor circuit. So hybrid parameters in transistor circuit. The transistor is equivalent to the 4-port device in which the 2 parameters, that is current and voltage, in the both sections. Suppose this one is a device. Here it is input port. This is input port, and here it is output port. The input port has current I1 and this is voltage V1. Here current I2 and voltage V2. This is equivalent to the circuit, that is this is collector, this is emitter, and here it is base. This one is NPN transistor, and here it is the plus VCC. There is load, and here it is the input. So the terminal points are something like this. That is, input is now base IB. Here it is VBE, and this current is IC, and the voltage is VCE. So currents I1, I2, voltage V1, V2. Here current IB and IC, voltage VBE and VCE, this voltage. The configuration is, this is CE configuration. This is CE configuration. Now, in this current and voltage two parameters, we can consider these two parameters are independent and two parameters are dependent. So we can transfer this transistor in the mathematical expressions. Why it is hybrid? Because we take voltage and current, two parameters, as independent parameter, and another two parameters are dependent parameters. So the hybrid parameters can be visualized as, so this is input parameter and here it is output parameter. This output P is um, voltage BC, this voltage CE, this IB, this IC. Now consider these two quantities, as independent quantities. So the mathematical function can be written as this VB is IB VCE, this is equation 1, and this IC is equal to function of IB and CE. The VBE and IC are the dependent variable. This is dependent variables. We can use the concept of partial differentiations as dVBE is expressed as delta VBE plus delta IB into DIB, this constant VCE plus delta VBE plus delta VCE into DVCE IB. This is equation 3, and DIC is delta IC upon delta IB, this small, into DIB VCE plus delta IC upon delta VCE into DVCE IB. This is equation 4, where the coefficients are expressed as HIE is equal to delta VBE plus delta IB VCE is, this is short circuited input impedance, and this FE is equal to delta IC upon delta IB. VCE is forward current gain, HRE is delta VBE upon delta VCE at IB constant. So you see, this is output voltage, this is input voltage. So in this case, ratio of input voltage upon output voltage, while it is gain is output upon input, so it is reverse. This is reverse voltage. This is reverse voltage gain in the open circuit. Here it is forward current gain in short circuit. short circuit, and the lastly HOE is equal to delta IC upon delta VCE. This is IB. This is this current over voltage. Normally voltage over current is resistance. So this value is 1 upon the resistance. So it is admittance. Admittance in open, in output circuits. So it is termed as output admittance. Output admittance in the open circuit. Output admittance in open circuit. So these four parameters, that is del V upon del B, is this one is short circuited input impedance. Here it is delta IC over delta IB. This is forward current gain in short circuited. This is delta V upon delta C, reverse voltage gain, because output upon input is voltage gain. Forward it is reverse because 1 upon this. Here it is output admittance. Admittance is 1 upon resistance. Admittance is 1 upon resistance. So this parameter is admittance. So we can substitute the coefficients in terms of these parameters, and then we can have this one. Equation 3 and 4. Substituting the values of H parameters in equations 3 and 4, we have, in equation 3 and 4, we have dVBE is equal to HIE into DIB plus HRB into DVCE. DIC is equal to HFE DIB plus HOE into DVCE. This one is equation number 1, 2, 3, 4, 5, and this one is equation number 6. So on the basis of this, we can express the above equations in the matrix form. As dVBE DIC is nothing but HIE HRE HFE HOE. This DIB DVCE. This is equation 7. So interestingly, you see this transistor circuit, this is this is nothing but an expression for the transistor circuit in CE configuration. And with the help of this expression, we can analyze many transistors on the basis of the above expression. We can analyze various transistor circuit. For this, we need the equivalent circuit. So we can plot this equivalent circuit of the transistor. So equivalent circuit can be drawn as in two parts. For the voltage and current as well. Kirchhoff voltage law say this dVBE is HIE into DIB plus HRE into dVCE. And Kirchhoff current law say, this law say DIC is equal to HFE DIB plus HOE DVCE. So here this voltage is sum of two voltages. This is V1 and here it is V2. V1 and V2. Here the current is sum of two part of currents. This is current I1 and this is current I2. If we draw the equivalent, so this is current, DIB is current, this is change in current. So current multiply with the factor is voltage, means that factor is resistance. So HIE is the resistance, that is input impedance. So the voltage equivalent circuit can be written as, this is HIE into DIB. This is. And the second V2 is reverse. V2 is reverse, so this can be drawn as, this is drawn as HRE into DVCE. This is the input. This is input section. This is the input section. And the output section is the current source. The current source, this is HFE into DIB, and this is admittance. Admittance is HRE into DVCE. This is DVC. So this is DIC is two part, one and this here. So Kirchhoff current law is operating over this point. So this is output section. This is the output section. And this output section is known as current source. Current source. Why this input section is voltage. Voltage source. And that's why it is hybrid. That's why it is hybrid, because this voltage and current section are. And this point is joint. This is joint. So this is the complete equivalent circuit. This is the complete equivalent circuit of the transistor CE configuration. CE configuration. So this is all about the today lecture, that is hybrid parameters and the equivalent circuit of this discussion, and this is all about the today lecture. Thank you.